personal introduction. My name is Daniel Paz. I work at Deutsche Bahn for a couple of years based in Berlin in the corporate venture capital team. Prior to that, I worked at a small bookstore from Seattle called Amazon. Amazon Web Services, I managed their business development for startups in Germany. And before that, worked as an entrepreneur. And I'll talk about my team in a moment. Please.
Yeah, thank you, Daniel. So my name is Chen, and I'm working in the think tank, digitalization and technology for the DB Holding, directly under the digital Vorstand. So we are like a small group of people. We are working on technology trends and the impact for the company, more or less the strategical way, but also what should we do as such a big, huge company? How should we deal with these technologies and also with the external market? Different companies, they are leading the trends, and how should we keep up with them? And the other more exciting question is how do we leverage this development outside of the market? And talking about me, myself, I joined the think tank in Berlin approximately 2 years ago. And before I was in Frankfurt from here, so I'm very happy to come back, my hometown. As a project manager, I was leading big IT projects to make software for DBNets. So I think this more or less this practical experience plus my strategical current work, for me, it's very, very good to understand the digital twin topic. And today I would maybe Daniel would first give you a very short introduction about our company, although everybody knows DB, but still some facts and numbers you want to give you.
Yeah, so both Yin and I touched the digital twin at DB, which is why we thought to come here and today explain shortly what we're working on. But just to give a very quick overview of DB Group to maybe not everybody knows. So big scale of public transportation. DB builds, maintains the infrastructure around rail across Germany. The stations, the tracks, you can see some figures here. But not only trains, DB owns DB Schenker, the third largest logistics company in the world, which somewhere between 4 to 5% of the world logistics, depends on which field area, is handled by Schenker. I think the most used app in Germany is the DB Navigator. DB has fleets of cars, bikes, trucks, buses, light rail, fast rail, cargo rail. Large scale, and a lot of intermodal, both for cargo and passengers. A little bit on the units, because we're a big group. So we have the rail side there with the IC, like high speed, and the regional. Arriva, which actually operates outside of Germany in buses like UK and North Europe. On logistics, we touched about DB Cargo and Schenker. The infrastructure is DB Nets that has basically all the infrastructure, but under that the tracks. Bringing the power to the lines is by DB Energy. There's also the power over the lines. DB Engineering and Consulting is another international unit we have that works like in 100 countries or so. And there it accompanies railway engineering projects in the functional level. So we are present, I think, in most countries in the world by Schenker and DB&C. Please, Ian.
So, you have just heard how complicated and big-scaled our company is. I'm still very amazed by it. Sometimes people just come to me and ask, so, Ian, can you tell me why my train yesterday got cancelled? I would love to answer this question, but I'm afraid that I'm not an expert in every operational thing. So once we talk about digital twin, CTO and also my boss, the Vorstand, was talking about, hey, this is a hype trend. We want to attack this area. We want to understand the impact of a digital twin for DB. But we just saw that the company is so big, consisting a lot of subsidiaries, a lot of business, also abroad. So how do we actually imagine digital twin for the whole DB group? So we see it's necessary to think of, to make a vision, and maybe it's better to make it graphical. So we'll make it easy, understandable. So maybe any one of you have seen this picture before? Just raise the hand. Not single one. That's very good, because that's why I'm here today, to introduce this. And yeah, like I said, we wanted to understand the digital twin vision for the whole company better. So what we do, we organized 5 workshops. We invited approximately 40 experts from the whole DB, including the infrastructure experts, including the train experts, the vehicle experts, also including logistic colleagues from DB Schenker and so vice versa, to have hopefully a completed view about it. So after this 5 workshops, we put this acknowledgement and this information together into this picture. So as you can see, we try to portray the real railway world into this picture. You can see that trains are driving on the rail, and we have train stations, and we have this like say garage for the trains to have them repaired, and we have also areas where we own the buildings where these trains are parking, but also but we are not separated in the world, okay? So we have to interact with the outside world, which is, you see the weather, the trees, the geographically natures, and if we talk about logistic, we also don't work isolated. We have to work together with ships, with planes, with I don't know, airport, whatever. But this is a system we are operating, okay? And then you see the digital twin. The most simplest idea is just to make a twin, make a replica of every technical asset. So we talk about train twins. We talk about the garage twins, we talk about rail twins, but here also don't forget the people, customers. They're also in the whole picture, okay? And container twins, the logistic, and the whole globe, weather, climate. So what we do is we just imagine if we have this single components as twin, we model them. What can we do with them? So I added the story level in this vision picture to just imagine what can we possibly do with them for the whole system. So I will give you a very short introduction to 3 examples in these 8 stories. Maybe you have time later to have a little bit holistic view. So the first story I'm going to talk about is the collaborations in the railway industry along the value chain, which means we want to exchange the digital twin, the train digital twin, with the manufacturers, and with we ourselves, we are operators, and also with the maintenance companies, right? What does that mean? Which means that a train actually has this life cycle, which means the first step has to be manufactured from a Siemens, from a Bombardier or Hitachi, right? And then it handed over to DB, and DB runs the trains on the rail and make it sure that it transport people and goods from A to B on time, hopefully. And then once the train is having a problem, it needs to be repaired. So we have to involve the maintenance companies. The problem is, who owns the digital twin, right? Or what do you think? Who should own the digital twin? Who has the data? Who has the original model of the train? Logically, the manufacturer, right? Because they made it, they have to have some CAD model and whatever the performance model. So why don't we just share the twins? But then you might have the question, why, if I'm Siemens, why should I share a twin with you, operators, right? Well, you can be a little bit creative on this. The manufacturers might be interested also in the operational data from DB, from us, from our operators, because with this data, they can understand their own product better. In the future, it can make better products. So there is possibly a win-win situation. So why don't we just work together? And also because the train itself, it went through different organizations. So we have to work together. We have to make the value of the twin maximize. So that's the first story where I personally believe that we have to cooperate with each other. Another one I want to talk about is very typically AI-based digital twin or AI-supported digital twin, which means, okay, so we are operating, means that we have to dispatch. We dispatch the trains on the rail, which means, okay, I have a crossing. This is very simply speaking, crossing. And according to plan, the train A should go first, and then the train B, and then the train C, and then you have everything according to plan. But what if something happens? Train A is not punctual. I have a problem now. So do I change the plan? How do I change plan based on experiences? Well, that's in many cases really happening nowadays, that people sitting there in some house watching, okay, you see, okay, train B, you drive. I hope that we got at least a late situation. But how can I make sure that it's really reflecting the real case? Do I have a monitoring on this? Well, if we have the monitoring, we can actually theoretically use different kinds of mathematical model, machine learning, and also just let's say a tree, just go the all possible alternatives 100 times, maybe 200 times. And then this agent, this intelligence twin of the real will tell you, hey, I calculated version 1, let train B goes first at what time, and then train C. In this variation, I can tell you as a digital twin that in this regional area, it is the best solution, okay? But we can also, if we have even more data from the whole Germany network, I can even tell you, okay, if you let this version work, then I might have a best solution for the whole German network, resulting in, well, averagely the least late and also maybe cost less, right? If I have this data. So that is the case. And fortunately, we're already working on that. So I'm going to talk about what we work on our visions, because the vision sounds like a little bit like 20 years ahead from now, but actually this vision is quite near us. We are already working on that. Another case, a little bit different, is a logistical case. Actually, I have a similar case with people, ETA and regional Bahn, but I think this, if you understand this case, you will also logically understand the people transport. So we just talk about a very simple physical asset and the twin of a physical asset. Here we are talking about a user journey, which means a whole journey from A to B. In this case, it's a good journey. It means that transporting the goods from Beijing or from Shanghai to Germany, for example. And it will go through different forwarders and different logistic providers. In this case, Schenker is interested because Schenker is one of our subsidiary. If I'm the customer of Schenker, like I see, I'm BMW, for example. I need my electronic vehicle to be transported to the biggest market in the world, China, right? I want to know where my car is, in which country. Are these cars going to face the custom problem? Or because it's electronic cars, the battery is actually one of the danger goods category. So in China, somewhere it needs to be reloaded to trucks. Do I have this as an overview? If I know it, I can plan better. I can tell my customer, hey, my cars will arrive in your country within 30 days. With 1 day delay, I can pay you whatever, right? So you need this information and across the whole globe. And if I have the digital twin, somehow the correct information, I can, as Schenker, I can offer my customer a better solution, right? So, but similarly with person, with a single individual customer, that means that if you travel from your home to here to the conference, right? You travel by train, and we want to, as a train provider, we want to offer you the best experience, which means even if the train is delayed or canceled, do you maybe get alternative advices how to get here, right? But I think today we are still not that far yet. At least I see my colleagues are working at construction model of the train, where's a defect or where's okay. So I'm very happy that we are working on that. So how many minutes do I still have? I tend to talk a little bit more. And the second part, thank you. My colleague also has the second part, so I think I only get 2 minutes maybe. The mission and challenges we have. I just talked about the vision, how the whole world might look like. One thing we shouldn't forget is about the weather and weather impact, the climate impact on the whole railway system. It sounds very unimportant, but it is not. Why? For example, if it's snowing quite hard in winter, then the train, the rail needs to be prepared for the snow need to be get rid of, and this need a lot of work. You have to assign people to do it. The thing is, we don't know when it snows. If it snowed, we have to send the people out. But how do we plan? How do we have the certainty of this plan, right? And also, if the weather turns very hot in the summer, you might have this bad experience that some kind of ETA just don't drive anymore. But if we know it in a little bit in advance, let's say just 1 day before or 2 days before, and hopefully we have a connected system, we can say, okay, we can prepare some kind of solutions for that to make the customer feel a little bit better, and also prepare a technical solution for the aircon. The aircon is a very big problem, believe me. And now it comes to what kind of challenges we are facing and what is our mission. As I said, connecting the dots, connecting people, shift the value. The first challenge we are facing is the digital twin is not a single technology. It incorporates a lot of technologies, which I would say, what is the necessary part, obligatory part in digital twin? I would say data modeling cannot be missing, right? The simulation part is a very empowering part, can also not be missing. IoT part is also very, very important, because without it, we don't know where the current situation is. Then digital twin is not a twin anymore, it's just a model, right? Every other component, like AI, I would say it's nice to have. It makes your twin intelligent. The AR, VR is also very nice to have, because it makes your twin interactable in a beautiful way, okay? HPC, okay, maybe if I put a whole railway system into a digital twin system, oh my God, what kind of calculation performance do you need? So high performance computer, maybe a quantum computing, like my boss always preferred, could be a important thing, but maybe it's not. So it's so complicated. How do we do with it? How do we deal with it? At the DB, fortunately, I think we don't have to start from zero. Why? Because we already have a lot of artifacts. We already have a lot of systems and solutions. The question is not what do we invent right now. The question is rather, how do we integrate them together in a logical way, so that we can use it, we can present them in a digital twin way to the outside world, to help us to better decision. So second challenge, fill the gap of life cycle. Let's take the BIM as example of infrastructure. Infrastructure, I mean the bridges, I mean the buildings, right? We talk a lot in the morning, I think. People were always talking, hey, you are BIM people. We have a BIM organization within DBNet who are only doing BIM work. And now I talk about digital twin. What is the differences between the two? So actually, if you look at the whole life cycle of a building, it's actually quite simple to understand. If you only build a building in the building phase, right? You digitalize it, 2D or 3D, and you let people collaborate, the architect collaborate with building companies, right? You know the information better, you have the model, it's good. And then the building is built, and that's it. What is afterwards? What is the operation phase? So the building needs to be used for, I don't know, 70, 80 years. And what is it that building, some part of it is old, is changed, need to be fixed, right? And so what is about that? The information cannot be found. And the information, if it can be found, it's not necessarily actual. So how do we deal with that? And then the digital twin comes into this field. So it's about filling the gaps of the life cycle of an asset, right? And also in the end, building might be eliminated. And you also need the information from the very initial building phase, right? So this is the second challenge. The third challenge is, as I said, we are a railways whole system. It consists not only infrastructure, but also the trains, the mobile part, but also the customer part, and the climate part. So the work is how to integrate the whole information and also the impact with each other. This is, for me, a very, very big challenge. And this has been talked, I hope, in the morning a little bit. Why do we do digital twins? We don't just build digital twins to entertain ourselves, right? It sounds very popular, it sounds very hype, but we need digital twin to support different decisions. So it might be a little bit direction for you to guide how you utilize digital twin in different phases or in different categories. Operational, which means, okay, in this moment, how do I decide? Which way, left or right, do I go? I need some, agency help, assistant help, like digital twin to tell me, hey, I already calculated within 1 second. This way, better. This is operational. Tactical, okay, the train is delayed. How do I do the new plan for it? Next week. Technical. Strategic. Now it's Corona. So do we build less infrastructure due to this less demand for next year or maybe next 5 years? How do I foresee the whole population development? That's strategical. All of this could have a digital twin to assist it. So I hope this can help you to design a digital twin services. That's what we do within DB. Not only the solutions, but also we united the people together in a community, which I hosted. I founded in the year 2020, in the beginning of 2020. And what we do is we let people exchange different project experiences. We invite a lot of companies, startups to talk about their experience. We co-create also with startups, and we also do some research ourselves in a cooperation with universities and institutes, and we organize different interest groups for people to together collaboratively solve some common problems. And today, we have already built up a very big network of the community. As you can see, internally within DB, we have members, approximately around 130 from more than 14 companies within DB, and we have external partners, as is like Microsoft, like Fraunhofer EST Institute, around like 13, 15. And we are still very open to you. So if you say, I think we might be able to talk about the digital twin cooperation, just come to me, and we will say maybe we will see you in the next community. I'll give to my colleague, Dania.
Ian, our company is missing from your slide, the venture capital.
Oh, sorry. I will add that.
No, it's really amazing. Ian founded the meetup community for digital twin that brings people together, and we're in different countries. We don't know each other, and that's the exchange platform. And it's really exciting to see what everyone is working actually in a bottom-up approach in different projects around the company, and it's really inspiring. That's how we can exchange. I'll try to run quickly, 5 minutes. So that's like 30 seconds for startup. I wanted to show you disruptive technologies that we invested in or we're currently exploring. every session I've seen today was touching on these technologies. So I think it's nice to see what's coming ahead of the curve. Oops, that was quick. Basically, we look at a bunch of stuff that can help railway. I won't go through it, but it's a lot of different tech to make the trains run. One company, we just led a seed round from California, developed this tiny chip over here. This is the size. It's a IP design chip that's supposed to cost 20 cents per active label. To replace RFID, these chips are attached to a printed battery. They're like a sticker that is a computer, two-dimensional computer. The stickers talk to each other, create a network, and basically you can do tons of stuff. You can add sensors to them. They already have a temperature sensor and Bluetooth antenna. It can disrupt e-commerce, disrupt intralogistics. When you disassemble a train, you can tag every part. You can see where assets are, and it actively transmits, and the chips connect with each other, mesh networked, and find a way out to the cloud. So it's enough that the driver has a cell phone, the entire truck gets uploaded, even if it's 10,000 sunglasses, every one of them gets transmitted to the cloud, or 100,000 iPhones, really item level tracking. And this is something we at Deutsche Bahn and Deutsche Telekom are actively developing. Gideon Brothers, actually from Europe, from Croatia. Our Schenker just was part of a big Series A. This is a robot for warehousing that developed their own stereo camera with semantic view, very precise visual navigation, so VSLAM. It allows for the robot to be collaborative. It sees where people are, where pallets are. Then they took off this lift bot and conveyor bot, the camera, partnered with manufacturers of forklifts. And it's a pretty much fully autonomous forklift that can load and unload a truck, even if it's double stacked. There's very little companies in the world where the robot is collaborative and safe, certified safe. So you don't need to take people out of the warehouse, and you don't need to tell the robot what it needs to do by programming it. You can just tell the robot, follow me. Even if there's 100 people, the robot keeps following the one employee with all the tools on it. So that's very exciting. Kepler, a company we invested in the past, just I think is doing a big Series C now. Low orbit nano satellites from Canada. The low orbit and a lot of technology in it is made for ultra high bandwidth for IoT devices to allow a global coverage of assets. Also doing well. They already have enough satellites to cover the globe. We're one of our portfolio companies. Volocopter, where Schenker co-led the Series C for Volocopter, specifically to develop the Volodrone. So Volocopter is mostly an air taxi model, but here it's a logistics model that can carry a couple of hundreds of kilograms, at least 200. Cooperation with John Deere for agriculture, cooperation with Schenker for logistics, something we're working on. They're all connected to digital twins, I forgot to tell you, right? Monolith is digitizing your supply chain. Kepler also. Volocopter has a lot of digital twins on their batteries and their devices. Via Robotics makes industrial robots safe in manufacturing because they monitor the whole area around the industrial robot, so you don't need cages anymore. They're also TÜV Rheinland certified, and they're going to disrupt manufacturing. So you can walk in a car production line between the robots and not get hurt. You might get cut by a laser, but not from the robot arm. So that's a digital twin on the highest grade patent-protected system for indoors, right? ClimaCell, digital twin of weather, micro, hyper, local weather forecast. You just say what your employees need to do and which weather conditions they need. And ClimaCell gives you working conditions for each team member when they can or can't work. Viezo, that tiny vibration charging sensor. So I think this is attached to a railway, and when the train goes, it just shakes the sensor. It's an old concept, but it's a very new material that they use here that is kind of disrupting the area of charging by motion. And this is important for digital twin, because once you can recharge and communicate wirelessly, then you can deploy sensors in a much efficient way. Therefore, as Yin said, your digital twin is more rich. Actually, it's a live representation. Thank you for listening. I'm sorry I had to run through the. It's
my fault.
Yeah, it's a usual. Okay. Thanks everyone, and we have a round table, and you can come talk to us later.